Yes, it is.
Okay. So, math review. Since this is an algebra-based physics class, the first thing we're going to review is algebra. We don't do too complicated of algebra here, but let's do a little bit of a review. First of all, there are two different things you can do to an equation. I'll try you out what an equation is, though. Let's say there's some physical quantity which will represent with an x that you want to figure out what it is. And let's say that through whatever reason, you came up with an equation that's something like 5x plus 16 is equal to 21, something like that, okay? We want to solve for something for this x here. There's two principles that you can do to solve algebraic equations for an x. One is to multiply both sides of this equation by the same thing, or do to both sides of this equation the same thing. And the other thing that you can do is you can multiply any one of these terms by 1. And by doing lots of practice, you'll figure out the tricks on what will make this the most effective. It'll be the most effective way to get this. You're trying to get x by itself. That's what the goal is. So on this equation, what would be the first thing that I would do? Probably the best thing, yeah, subtract 16 from both sides, okay? So you do minus 16 from both sides, and then you would get 5x is equal to what? 5, yeah. Carefully chosen problem. Now, if I want to get x by itself, the next thing I would do is probably divide both sides of this equation by 5. So x is equal to 1. All right, that's the simplest type of thing you can do. That's a simple type of equation. What we did is same thing to both sides of the equation. We haven't multiplied by 1 yet. One thing that this brings up, it's good to write an equation. So a lot of times on homeworks you'd see a statement written like this. 5x, something like that. And this is a meaningless statement. There's no logical statement here. It's just there's no equation. So it's hard to do the same thing to both sides of this equation. This is left-hand side, this is right-hand side of the equation. You have to have both sides to have a logical statement, okay? All right, let's go on to next order of complexity. Let's say that I have something like this. Let's say I have 5x squared is equal to 10. What would you do for something like that? First step, do both things to both sides, same thing to both sides of the equation. Divide by 5, so you get x squared is equal to 2. Right? Now what do you do to get x by itself? Square root both sides. So what I have here is x is equal to square root of 2. Is that correct? Could be plus or minus. And that's something that you have to be a little bit careful with the square roots. In real physics problems, you'll pick the sign based on what's physical, okay? Pick sign based on physical argument. So for instance, this is something that you'll see in about a week. If I drop something from a height h above the ground, there's a relation between that height and the time it takes to hit the ground. That relation is that the height, so let me just draw this problem. So let's say I drop a ball from a height h above the ground. The height will be equal to 1/2 times something called g times the time squared. G is a number on the Earth, which is 9.8, and then it has these units. We'll worry all about this stuff in a week. But let's say I have something like this. H is 1/2 gt squared. If I want to figure out the time, I'm going to solve for it. So I got to do a little work. So the first thing I'd do probably is multiply both sides by 2. So 2, 2. I get 2h is equal to g squared. The next thing I'd do is I might divide through by a g. So 2h divided by g is equal to t squared. And then the next thing I'd do is take a square root. So I get square root of 2h over g is equal to t. Now, there's this technically, mathematically, this would be plus or minus, right? What does it mean to have a negative time be the amount of time that it took to fall? It doesn't make any sense, does it? So by physics, you'd say, okay, it takes a positive amount of time to fall. I don't even know what a negative amount of time is. That doesn't make sense. So I would take the plus sign here, okay, as the amount of time it took to fall. So the physics will give you that sign, or should. Sometimes it's less obvious than others. All right, let's do another example problem. Let's say I'm dealing with something that looks like this. And I want to figure out what x is. What would I do there?
Subtract 20.
Yes, you subtract 20 from both sides. So minus 20, and I get 1 over x is equal to minus 10, right? Now what would I do?
Multiply by x.
Take the reciprocal of both sides. 1 over both sides. You can do the same thing on both sides. So I get x is equal to 1 over minus 10. That's the same thing as minus 110. 0.1 with the minus sign. Okay? All right. Good. Let's say I have something a little bit more complicated. Let's say I have something like x to the 4th is equal to 1. How did I get x by itself? Square root twice. Okay. Yeah, I guess you could do something like that. How would you do it on your calculator, do you think?
Well, it depends on what calculator you have.
Depends on what calculator, but usually there's something like a y to the x thing here, or something like that. What I would do here is I'd take it to the 1/4 power on each side. Okay? So x to the 4th, 1/4 equals 1/4. Okay? So if I have a power taken to another power, those two things multiply together. Okay? So this would just be x. And this would be 1 to the 1/4. There's actually 4 solutions to this, but if we're dealing with just, let's say, real positive things, we can just take it as 1. Okay? Maybe plus or minus 1 if we're dealing with real things. Make sense? That if you're trying to get something, some power to its by itself, you'll take it to the reciprocal of that power. So for instance, square root is the same as exponent to the 1/2. All right, we'll do two other types of problems that seem to come up as far as algebra review is concerned. One is a fraction one. Let's say that I have something like, let's see, say I have 1 over x plus 5 over 2x is equal to 1. And I want to get x by itself. What would I do here?
The common denominator.
That's right. You have to have a common denominator if we're adding fractions. You guys remember that? So if I'm adding 1/2 and 1/3 of an apple, that's like, you know, it's tough to do, but if I say that, you know, 1/2 is 3/6 of an apple, and 1/3 is 2/6 of an apple, you know, then I can see that I have 5/6 of an apple there. All right, I mean, so here I gotta get a common denominator. I'm gonna use that other algebra trick that we can do, which is multiply a term by 1. So I'm gonna write 1 over here as 2 over 2. Remember with fractions, if you're multiplying fractions, you multiply numerator, you multiply denominator. So this would be 2 over 2x plus 5 over 2x is equal to 1. Once I have something like this over a common denominator, I just add the numerator, the top part. So I get 7 over 2x is equal to 1. If I wanted to get x by itself, what would I do?
Oh,
First I take the reciprocal. So I do 2x over 7 is equal to 1. Then I could divide by 2/7, right? Or multiply both sides by 7/2. Either way. And so this would be x is equal to 7/2. You follow that? So with fractions, find common denominator and then add them and then do what you would do, add the numerators and then do what you would do for any other algebra problem.
Can we do like cross multiply once we get to the common denominator?
Oh, like here? Like,
No, on top like 5, so it'd be 7. It'd
Equals
be,
2x.
yeah,
here?
Multiply both sides by 2x.
like 7
Oh,
equals
yeah, yeah,
2x.
yeah. Yeah, you
And
can
then
do
you
that.
get 2x equals 7.
Yeah,
Then
and
just
you
by
don't
the
have to
2.
do the whole entire bottom.
Yeah, you can do this here. You can multiply both sides by 2x, and then you wouldn't have to take the reciprocal. So you
Yeah.
can do 7 is equal to 2x, and then
7 over 2.
7/2 is equal to x. Very good. So see how, you know, these two things are the same? There's usually with algebra problems, there's more than one way to get the right answer, or a lot of times, and every way is good. So you just can't, as long as you don't make a mistake. This way is simpler than the way I did, I think, but yeah, it gets to the same thing. Okay. So early on, we're going to be doing, next week, we're going to be doing something called kinematics, which is motion given an acceleration. We'll talk about what that means. In those types of problems, that we run into something that involves a square, something to its first power, and then something that's a constant. So you get something, equations involving x squared, x, and maybe just a constant. So for instance, an example of this would be like x squared plus maybe 3x plus 10 equals 0. So you get equations of this form. How do you solve those?
Yeah, I mean, factor.
You could try to factor it out, and sometimes that's the easiest way to do it. How do you factor this one? Ooh, I heard something.
The quadratic.
Yeah. So probably the easiest thing to do is once you have it in a form, and there could even be a constant here, you just use what's called the quadratic formula. Okay? And I can, if you're interested, I can show you where that comes from. It comes from completing a square, but basically, if you have this type of equation, let's just plug it into a quadratic formula. So if I have an equation of the form ax squared plus bx plus c, where a, b, and c are constants equal to 0, then x is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Very good. So there'd be two possible solutions. So let's apply that to this one. So I would get, so for that one with the numbers, x squared plus 3x plus 10 is equal to 0. What I would do is I'd see that a is equal to 1, b is equal to 3, c is equal to 10 in the quadratic formula. Okay? And then I just plug in numbers. So I'd say x is negative 3 plus or minus the square root of b squared, which is 9, minus 4 times ac, which is 10, so minus 40. This isn't a very good example, actually. All over 2. And I'd have an imaginary number in here, a square root of the negative number. So if you get something like that, you probably made a mistake on your equations. Because they won't arise, they shouldn't arise in this class. Let's try something a little bit that might work. So let's say I have x squared plus 5x minus 10 is equal to 0. Okay. So in this case, a would be 1. B would be 5, and C would be negative 10, right? Good. So that means x would be negative b, so negative 5, plus or minus the square root of 5 squared, 25, minus 4ac, so ac is negative 10, so minus negative 40.
You mean to write 25 or 24?
What's that?
24.
Oh. Yes, very good. Thank you very much. All over 2. All right. So this would be x is equal to negative 5 halves plus or minus square root of 65 over 2. All right. This is pretty close to 8, and so that would be, plus or minus 4, but pretty close, not exact. But you plug it into your calculator if you want to get a decimal, or leave it like that. Yes.
Do you prefer decimals, or would you rather answer like that?
Frankly, I like answers like that.
Okay.
For lab stuff where you have to have a number, decimals are nice, but for this class, I really like, simplified square roots would be just fine. Okay. All right, so that's quadratic formula. Let's move on to some units now. All right, this should be more, well, let's do one more, we'll do one more example, okay? One more example. This is one that, why don't you guys take a little bit of time, 5 minutes, to try doing this one on your own. It combines a lot of what we did, okay? this problem is 1 over x plus 2 over 1 plus x is equal to 1. Solve for x. Remember, with fractions, you want a common denominator first. Raise your hand if you have an answer. You know how to do it?
I multiply by
This is just one point by one.
Oh.
Two.
How do you
By 2 over 3.
yeah, so 2 over 2. Oh, so you don't have to answer that. Okay.
Not seriously. It just says one by last. I know it.
All right, you ready to do this? I think we've probably gone as far as you can. You know, if you know how to do this, you can probably get it in that time. So this one, we got to put this over a common denominator, right?